Hello, welcome back to our statistical learning session. Today we'll be talking about a test based on MLE. This is called Wall's test. In previous lessons, we have done a simpler test using natural estimator. For example, that's what we did in KISS example. But in this case, we'll use a more sophisticated version of estimation. And this is called maximum likelihood estimator. There is a theorem for maximum likelihood estimator for asymptotic distribution, which we study in chapter 3, and we'll be using that in this case. Emily can be average or not, and with asymptotic normality, we can build test using Emily. And what kind of test do we need? We need test that depends upon asymptotic distribution that doesn't depend on any parameter. And for that, we need to rescale the Emily or maximum likelihood estimator. Now let's begin. Let's assume that we have IID of sample x1 through xn with a statistical model with a sample space E and probability distribution of E with a parameter P with theta that belongs to a parameter set theta, big theta, which which is which belongs to RD dimension, where D is greater than 1. Now let's assume that theta naught belongs to parameter set big theta and is fixed and given. Now let's assume we have two hypotheses. One hypothesis says that the theta parameter theta is equal to theta naught, and alternative is theta is not equal to theta naught. Now we need to estimate theta using a parameter. Now what we'll be doing will be we don't know what theta is, so we need to estimate that using theta naught MLE. So what we are saying is that we have theta naught and we have a theta, and we need to estimate what's the distance between these two. We need to estimate what is the distance between these two. And that's how we will estimate the this thing. Now next step, what we need to do, we need to second step. Now next step is to next step is to next step is to use our MLE theorem to get a statement about theta MLE, that is square root of n theta theta MLE minus theta equal to theta MLE theta equal to distribution D, where as n goes asymptotic, it has a distribution of zero mean, normal distribution zero mean with the Fisher information I and theta minus -1. This is what we have. Now we need to transform this into something that is doesn't depend on Fisher information. And to do that, we will multiply by square root of Fisher information on both sides. Square Fisher information both sides, which will give us I theta n 0 I theta minus 1, and which will eventually give us n 0 1. Now we have a statement that we are looking for. Therefore, we can say that now what we can say is that if h0 is true, that means if theta is equal to theta naught, then we can just replace this theta by theta naught, and same time put n here and I square root of the guy, and thus we get this statement. Now there are different versions of this. We can also say the same. We can also replace theta with two different things. There are other versions of this too. Now let's see. The different hypotheses can be h. H can be h star, which is a true parameter, and it's a theta naught. And h1 will be h star theta naught, not equal to theta naught. It's a version 1. And another version can be theta mle equal to theta naught and theta mle not equal to theta naught. There are different versions of this, and that's what we have here. And if that happens, then we will just simply change this to this n. Theta becomes theta star square root theta n becomes theta mle, and that's what we have. Therefore, what we discussed today is we created a hypothesis test where null hypothesis was theta is equal to theta naught, and null alternate hypothesis was theta is not equal to theta naught, provided that we have an x distribution x in a sample space E with parameter p theta that belongs to the RD distribution, RD dimension, and theta naught is belongs to theta parameter set which is fixed and given. And this can be still modified into different ways as we required, such as we can say that instead of theta we can just theta true parameter theta star, or we can say that theta is a theta mle, and this still holds true to this, and this should be still equal to theta mle theta star theta mle theta. This still hold true, and it will be still the same distribution D ND0ID. So that's what we did here. We need to see how close these are. The Sarah Emily is how close to Sarah, and for that we have done this kind of calculation here. So that's for today. I'll see you next learning session. Thank you so much.